Hi to everyone. My name is G. Pranit. I am from CSCE section. My complex engineering problem is interpreter. Introduction. An interpreter is a program that directly executes instruction written in a programming or a scripting language, translating them line by line. Unlike a compiler which translates the entire programs into machine code at once, an interpreter processes the code one statement at a time. This slide introduces the need for interpreter in programming language and highlights their role in real-time code execution. The discussion should touch on common language that has interpreted. Example Python, JavaScript. Difference between compiler and interpreter. Compiler translates the entire program code into machine code, producing an independent executable file. It processes the entire source code before any part of the program is executed. Interpreter means translating code line by line into machine code, executing it as it reads. This makes interpreters slower than compiler but useful for debugging and dynamic code execution. Key points to cover: speed, execution method, error handling, and resource usage. Example Java compiled to bitcode interpreted by JVM versus and Python directly interpreted. Types of interpreters: simple interpreter directly interpreted each instructor without conversion to an intermediate form. Example Python. Bytecode interpreter converted high level code into bytecode first and intermediate lower level code which is then executed by a virtual machine. Example Java. Just in time JIT interpreter compile code into machine code at runtime to speed up execution, commonly used in modern language like JavaScript via V8 engine and Java. Components of an interpreter. The interpreter consists of several essential components that works together to convert high-level code into machine-readable instruction. This includes lexical analyzer, lexer, scans the code and splits into tokens like keywords, operation, identifiers, etc. Bracers analyzes the syntactic structure of the code, ensuring it adheres to the rules of the language. Semantic analyzer ensures the code is logically valid. Example variable type checking. Interpreter engine executes the code, translating it into machine instructions in real time. Lexical analysis means process involves breaking the source code into tokens. This is the first stage of processing and is crucial for recognizing the structure of the codes. Tokens are categorized into keywords, identifiers, constants, operators, and delimiters. The lexer generates a token stream that is passed to the parser for future processing. Syntax and semantic analysis. Syntax analysis means parsing. The parser checks whether the sequence of tokens follows the grammar rules of the language. Example matching parentheses or valid expression. Semantic analysis means the semantic analyzer ensures that the program's logic is valid. For instance, it checks for type mismatches or user of undeclared variable. A program might passes the syntax analysis but fail semantic analysis. Division by zero and uninitialized variables. Intermediate code generation. After syntax and semantic analysis, an intermediate code is often generated, which is a lower level representation of the code, but not at machine specific. This intermediate code allows easier optimization and can be executed by a virtual machine. Bitcode is a prime example of intermediate code used by Java. Code execution process. Once the code passes through lexical syntax and semantic analysis and intermediate code generation, the interpreter begins the execution process. Interpretation means the interpreter translates the code line by line or instruction by instruction. For JIT interpreter, the code is translated into machine code during execution to optimize performance. Error handling in interpreters. Interpreters detect error during execution rather than compile time. Errors can be syntax error, runtime error, or logical error. Incorrect program behavior. Runtime error means division by zero. Syntax error is in invalid code structure. Interpreter provides immediate feedback, which is beneficial for debugging but can slow down the execution. Performance consideration. Interpreters are generally slower than compiler because they translate and execute code line by line. However, they offer flexibility as they allow for dynamic code execution. JIT interpreters and bitcode execution can mitigate some of these performance concerns, but they still typically lag behind compiled languages in raw execution speed. Applications of interpreter. Scripting language like Python, Perl, and Ruby use interpreter for task ranging from web development to system administration. Web development means interpreter, example JavaScript engines in browser, allow for dynamic web content and interactive web pages. Educational purpose. Interpreters are often used in teaching programming as they provide immediate feedback, making it easier for beginners to understand and debug code. Advantages of interpreters. Portability. Since interpreters translates code at runtime, they can run on different platforms without requiring a recompile. Flexibility means they allow for interactive use and on the fly code execution, which is especially used in REPL. REPL means read eval print loop environment. Easy of debugging. Immediate feedback and error reporting make debugging easier and faster for developers. Disadvantages of interpreters. Slower execution. Interpreter tends to be slower than compiled language since they process code line by line. Memory usages. Memory usages. Interpreters may require more memory during execution as they store the logical source code alongside that translated machine code. Modern use cases of interpreters. Web browser. JavaScript interpreters like V8 engine allow for efficient execution of dynamic web content. Dynamic languages. Python, Ruby, and Perl are commonly interpreted, providing flexibility for rapid development. Embedded systems. Embedded systems. Interpreters are used in systems where resource constraints are less stringent and flexible is a priority. Interpreter design challenges. Discuss challenges in interpreter design. Efficiency. Interpreters are typically slower than compiler requiring. Optimization techniques like JIT compilation. Memory usage. Managing memory for both source code and interpreter code can be difficult. Error handling. Providing helpful and accurate error messages for end users can be complex, especially with dynamic languages. Interpreter versus compiler, a comparison. In this slide, summarize the key difference between interpreter and compiler with a direct comparison. Speed. Compiler generate faster executable. Execution. Interpreter can execute code line by line. Error handling. Interpreters detect errors at runtime, while compilers detect them at compile time. Memory usage. Interpreters use more memory as they need to store the source code and the interpreted version. Discuss challenges in interpreter design. Efficiency interpreters are typically slower than compilers, requiring optimization technique like JIT compilation. Memory usage. Managing memory for both source code and interpreted code can be difficult. Error handling. Providing helpful and accurate error message for end users can be complex, especially with dynamical language. Conclusion. In conclusion, interpreters play a vital role in programming, especially in scenarios requiring rapid development and debugging. Despite performance drawbacks compared to compilers, their flexibility and probability make them indispensable in modern software development. Thank you all.